All right, good evening. Welcome back to Pre-Calculus. So today we are going to go ahead and graph something in polar coordinates. Okay, so this is a worksheet that I gave my students to do. I said, okay, graph this function, r equals 1 minus 2 cosine theta. And there's some instructions. It says graph this on an r theta Cartesian coordinate graph first. So if you think about theta being x and r being y, that's the kind of thing I want you to graph. Okay, and then we're going to translate that to graphing this on polar coordinates, and we'll see what happens. Okay, this one's a little tricky. Okay, so the first thing I do is write down, like, okay, well, here's the thing. Here's the function we're going to draw. So graphing this on Cartesian coordinates, pretending it's not polar. I'm going to graph this as a theta axis, and then I'm going to graph this as an r, just like if I wrote x and y here. So how do I graph this? So what I have to do is think about, like, okay, what's this -2 doing, right? That's -2 is taking my cosine theta and flipping it, right? It's reflecting it about the theta axis here. So this guy, 'cause I need a little bit more room to go ahead and draw this thing all the way out. Okay, and normally the way we draw our trig functions, right, is we go ahead and we draw our 2 theta halfway between theta, or pi rather, halfway there, pi over 2, and halfway between 1 and 2 pi is going to be 3 over 2 pi. Okay, so if I go ahead and dot in my -2 cosine theta, we're going to say, okay, well, there's 1 cosine of pi over 2 is 0. And we're going to be a -1, so it's going to be -2 times -1 will be up here at 2. And then we're going to be down here. Okay, so I'm just going to dot in this little part here first. Okay, we'll pretend that I hit all the dots. Okay, now the next thing we have to do is say, well, what happens to this 1? Right? You remember from your college algebra class, your algebra 2 class, that 1 pretty much raises everything up. It's a vertical shift up. Okay, so the actual graph that I'm looking at, we'll do it in red, sure. Okay, because if you think about this thing, if this is all made out of pipe cleaners, right? We're just going to raise everything up by 1. Okay, so instead of 0, we're going to be up here at 1. Instead of 0, we're going to be up here at 1. Instead of negative, we're going to be up here at -1. 0, we're going to be up here at -1. Okay, so my actual graph is going to look something like this one. Okay, we'll pretend that that looks right. Okay, we'll pretend that looks good. It doesn't, but please forgive me for the crummy drawing. Okay, the next thing we have to do is we have to graph this on polar. Okay, so that's what we're going to do first. That's what we're going to do next, rather. So if I think about a polar coordinate graph, okay, so this is my angle, my theta is equal to 0. This is my theta is equal to pi over 2. So I'm just rotating it around. This will be theta equals pi. Should be theta equals 3 pi over 2. Now we could dot in some other things here, right? This would be like theta equals, we'll say theta equals pi over 6. Theta equals pi over 4. Theta equals pi over 3. And then how far away we are from the origin, that's going to be our r. Okay, so as I look for this one, okay, the first angle I want is the angle of 0. That would be in this direction. This is where this one gets tricky. So at 0, right, the angle 0, okay, r is -1. So I can't go forwards 1. I have to go backwards by 1. So we're going to actually be here. Actually, I'm going to change my pencil color to something else. Red is usually stress-inducing, so I don't like to do that one. Okay, do we have purple? Kind of. Hopefully this shows up. Not really. Maybe green. That's greenish. Okay, I apologize for that. Okay. Now, as we sweep from our 0 angle up to our pi over 2, so technically we're here. Okay, I'm sweeping this area here. We're going from 0 to pi over 2. But down here, it's negative. Okay, so it's negative until I get to this spot here. So I'm not really in the first quadrant. I got to think I'm going backwards. So I'm actually down here somewhere. So what's going to happen is we're going to get a curve like this. Okay, so normally I'd think I'm between 0 and pi over 2, but I'm going backwards. So we're over here. Okay, once I get to pi over 2, okay, now we're positive. We're positive 1. So what I'm going to do is I'm going to come up here. We're positive 1. We can take one step in the direction of pi over 2. So here we are. Okay. And then between pi over 2 and pi. Okay, so we know that we are in this part of the curve. We know we're in this part of the coordinate system. That is between pi over 2 and pi. And we are taking forward steps in these directions. So at pi over 2, I'm at 2. Right, we have that. And then from pi over 2 all the way out to pi, it's going to go from 1 up to 3. So we have 1, we'll say 2, 3. Okay, so this is going to go all the way out to here at 3. Okay, so we're just trying to make an arc here. You've got like a try to eyeball it, and maybe if you have a French curve set, you could do that to help you kind of graph this thing. Compass might help, but most people will say if you can freehand it, that's probably going to be fine. Okay, so out of here at pi, we are at 3. So in the direction of pi, that's over here. That's the direction of pi. We are 3 units out. Okay, now between pi and 3 pi over 2, that would be these angles down here. Okay, we're going to move between 3 all the way back down to 1. Okay, so here's 1 in the direction of 3 pi over 2. All right. So we're still above the axis. We haven't gone below the axis yet. So once we are past 3 pi over 2, there's a spot where it hits 0. So we should be past 3 pi over 2. So we should be in quadrant 4. We're over here somewhere. Okay. But this piece here actually connects back into the origin. Okay, because it crosses the axis. That would be this point right here that we just graphed. Okay. And now we technically are in quadrant 4, but we are not in the positive direction of quadrant 4. We have to walk backwards. So we're actually in quadrant 2. So we're going to come back around and we're going to end up with some kind of a ugula type thing. It's the thing that hangs down in the back of your throat, right? So that's what we're going to end up with, that piece back there. Okay, and that's how you graph a polar coordinate. Okay, graph that's of this form. Okay, calculators will obviously do a much better job than I ever did. Desmos will do a better job. But mostly when you're in pre-calculus, you're learning how to graph this stuff, because when you take Calc 2, not Calc 1, but Calc 2, you're going to be given the instruction. Figure out the arc length of this curve between, say, this point to that point. So they would do something like they want to know this arc length. And the first instruction is going to be sketch the region that you want the arc length for. You could do it on a graphing calculator if your school allows it, but mostly, it's going to get painfully old. So you always have to get out your graphing calculator to graph this thing. Okay, so I would urge you, if you're going on and you plan on taking Calculus 2 at some point in your life, at least learn the easy polar coordinates to graph. And then when you get to Calculus 2, you'll be able to do your homework in like a way where you won't die of old age by the time you finish it. Okay, so I hope that was a little helpful. Again, I'll try to link the pieces down below for this thing. And thank you for watching my video, and I hope that helped you.